Hi, so we'll be looking at understanding what we mean by simultaneous equations and how to solve simultaneous equations. And a method on how to do this is one method is using substitution. There is also elimination, which is in a different session. But first, we have to understand what we mean by simultaneous equations. Now, simultaneous simply means when two things are happening at the same time. We use it a lot in English. If two things occurred simultaneously, we're saying they happen at the exact same time. And we'll come back to what we mean by substitution and how to use it. Now, imagine these were two lines on a graph. I'll just, draw a graph that's not very straight, but anyway, or just two lines. Now, if we look at these two lines, now we know a line has every line has its own equation or linear equation. That's where simultaneous equations come in. Now, if you haven't learned how to draw straight lines when given an equation, a linear equation, that's fine. We can still work with this topic without knowing that just yet. Now, if we have a look at these two lines, so each line has its own equation, and if I asked you where do these lines have something in common? Where is the point that they have in common? You can see it's where they cross over. So just here is where they are simultaneous. And that is the point that we are trying to find when solving simultaneous equations. Now, to solve a simultaneous equation means to find the solution. And the solution is where the two lines cross over. And that's it. So we're going to be learning how to find this point without having to draw the graph. And just in case you haven't learned how to draw straight lines yet, that's fine. We can still find this point on the graph without having to draw them. And this means we are trying to find the solution. And the solution is these two lines share only one point in common. And it's that point right there. And we call it the solution. And for example, for this point here, I could say, well, just say imagine y was 5 here, and we'll say x was 2. Well, so the solution for this, for these two equations would be, well, simultaneous solution would be when x is 2 and y is 5. Now, this is not accurate. I've just made it up to show you. But the solution is simply one point, the one point they have in common. So this is going to be a key word you'll be hearing, you'll be hearing quite often. And just remember, the solution is where two straight lines cross over and share one point. And the solution is then simply one point, when x is something and when y is something. Now, if we have a look at these two equations, they are both linear equations. And just to recap, a linear equation is where the variables, in this case y and x, the highest power is 1. There's an invisible 1 here and there, and so also here. So these are linear equations, which means linear, the keyword in linear, if I wrote the word linear, what comes first? There is line in there. Linear, the keyword is line. So linear equations, if we were to draw these on a graph, they would each have their own straight line. Now, we can find where these two lines cross over, okay, and what point do they share without having to draw it. And the method we're using is substitution. So if you remember, substitution means to replace. And we can do this now. So using substitution, we are going to find the solution where these two lines cross over without having to draw them. So what you have to do is, with this example, I guess we've started with a more tricky one to understand, and that is, look at the first equation. We've got y equals something, and also down here y equals something. To use substitution, you have to make sure one equation is at least equal to everything. In this case, we can see y is the subject, so y equals everything. Now, I'm going to put brackets around this one here, 8 minus x, and when we use substitution, it's very important that we always substitute with brackets. So if you want to write that note down, it's extremely important. Whenever you substitute anything, you must substitute with brackets. Now, this is going to be the tricky part that you have to try and understand, and that is, see how it's saying y equals 8 minus x? Well, what I'm going to do is, I'm going to substitute and we know substitute means replace. This, since y equals all of this, I'm going to replace it with this y here, because I know y equals 8 minus x. So this y down here, I'm going to replace it with 8 minus x. So I've got my 8 minus x in brackets. In this example, we don't need the brackets, but I'll just put it in to get into the habit. 8 minus x equals x plus 2. So I'm going to remove the brackets because there's no number on the outside to expand it with. So that can disappear now. And now we can see why we had to do this. And that is, can we now solve this equation? Yes, we can. We've got an x on this side and x on that side, one unknown variable, which means we can solve it. Up here, I couldn't solve either equation because we had y and an x, y and an x. So now to solve this, we simply have to bring our x's together and then solve it. So my first step is, well, I'm going to bring this x here to this side. So I'm going to minus x and minus x. So I end up with 8. Now minus x is minus 2x equals, and there's a 2 just here. Just be careful with your negatives and positives. Now I'm going to, this 8 over here is positive. So my next step is, well, I'm going to minus 8, can go minus 8. So I end up having minus 2x and 2 minus 8. 2 minus 8 is negative 6. And our final step, I'll just squeeze it in, is divide by negative 2. Divide by negative 2. And so, x will equal negative 6 divided by negative 2 is positive 3. And so far I have found the point of my x value. And that is, I have found 3. And now I still need to find my y value. And to do that, all you have to do is substitute x equals 3 into either equation. We can call this equation 1 and call this equation 2. You decide, you pick. If x is 3 now, we have to find the y value. What is y? And I might pick equation 1. I'll just rewrite it. All right, so when x equals 3, we'll sub it into the equation to find out what y is. So when x equals 3, we have y equals 8 minus x. So I'm going to substitute it. So y equals 8 minus, instead of x, I now have 3. Substitute with brackets. So we end up with y equals 8 minus 3 is simply 5. And I have found my y value. And your final statement will be, therefore, we say the solution, and we know what we mean by solution. Solution is saying the point where these two lines cross over and share the same point. So therefore the solution is, and write the solution as a point, because that's what we have found, when x is 3 and when y is 5. And we're done. Now with our next question, the question is asking us to solve these two equations, or solve the following simultaneous equations using the substitution method. Okay, I didn't write the question up because it takes a bit too much time. All right, so now if you have a look at these two equations, they are both linear equations, they are both straight lines, and we know that because the highest power of each one is 1. Now, this one looks like a more standard linear equation, y equals everything. This one down here, it's not in the form of y equals mx plus c, but we don't have to rearrange it, because to use substitution, one of your equations has to have either y or x being the subject. And we can see here, the y here is equal to everything. So all I know now, if y equals all of this, I am going to substitute it for the y down there. And it's very important in this case, especially, you substitute with brackets. So we can write a little sentence explaining what we're doing. So sub in when y equals 3x minus 3. We're going to sub this in to the second equation. So we've got minus 5x plus 3. So now, instead of y, I'll change my color to make it more visible. Instead of 3 times y, I have 3 times 3x and minus 3. I've substituted it into the equation. Let's finish writing the rest of the equation, and that is this all equals 3. Okay, so I substituted because it's telling me y is 3x minus 3. So instead of the y down here, I'll put in 3x minus 3 using substitution. And now the whole point of this, the whole point of substituting equation 1 into equation 2 is now, if you have a look, I can solve this. I've got x and x as my variables, and they're the same variable, and I can solve it. So now let's expand the brackets. So 3 times 3x and 3 times negative 3. So we have minus 5x, sorry, plus 3 times 3 is 9x. Oh, careful, it's a positive 3. Just keep that in mind. If that was a negative 3, we'd have minus 3 times 3x and minus 3 times minus 3. But we don't, so it's positive. And 3 times negative 3 is negative 9, and that all equals 3. Simplify the minus 5x plus 9. Well, minus 5x plus 9, I know, is 4x. Minus 9 equals 3. My next step is to, well, opposite of minus 9, I plus 9, plus 9. So down here I have 4x equals 3 plus 9 is 12. I'll just clear the page. So 4x equals 12. Well, divide by 4, divide by 4. And I'm left with x equals 12 divided by 4 is 3. And I have found my x value for my points. So far I've got x, but I still, so far I've got x, which is 3, but I still need to find my y value. And remember what this means. We had 2 straight lines in our question, and they cross over at a point. That's the point we're trying to find. And so far the x value is 3. We've got to find the y value now. And all we have to do is substitute when x is equal to 3 into either equation. It could be equation 1 or equation 2. I'll pick equation 1 because the question, it was easier because y equals everything. So we had y equals 3x minus 3 for equation 1. 3x minus 3. Just double check that. Okay, and we can say, well, just to write a sentence to explain what we're doing, we're going to substitute or sub in x equals 3 into equation 1. Now we should have labeled our equations at the beginning. I forgot to do that. All right, and now let's do that. So if x is 3, I'm going to replace this 3 for x over here. So I'll have y equals 3 times 3 minus 3. Remember, there's a times in between a number and a bracket. So y equals 9 minus 3. I'll squeeze it in here. So y equals 6. And we have found our y value for the solution. So our final answer. So we say, therefore, the solution is 3, when x is 3 and y is 6. And once again, I'm going to explain what this means. We started off with 2 straight lines. Imagine we drew them on a graph. That is where these 2 lines cross over. That is what that point is saying. This is where they are simultaneous, and simultaneous means where they are sharing the same thing or the same point. Okay, let's try one more question. Now this question here is different to the others because you notice instead of y equaling everything, we now have x equals everything. These 2 equations are both straight lines, are both linear equations. If we drew them, they'd give us straight lines, and we can see why. The highest power is 1 for everything. So the question that they're asking us to do is to solve these simultaneous equations using substitution. And this is easy because now x equals everything. So I'm going to substitute 14 plus 4y for the x in there. So we'll label our equations, equation 1 and equation 2. And we can simply say we're going to sub in, so sub in, you can write x equals 14 plus 4y, or sub in equation 1 into equation 2 because it's all done for us. So let's do that. So we have minus 2. Now instead of x, I'll change the color to emphasize it. We have 14 plus 4y, and we know we have to substitute with brackets. Plus 3y equals negative 18. So instead of 2x now, I've got 2 times what I've got in the brackets here because x equals all of that. We'll expand our brackets. So we end up with negative 28, because minus 2 times 14, and minus 2 times positive 4y, so negative 8y, and we've got plus 3y equals negative 18. Our next step is, well, minus 8y plus 3y, we can simplify that. So we still have negative 28. Minus 8 plus 3 gives us negative 5y equals negative 18. Now I can solve my y. I'll get rid of this negative 28. The opposite of negative 28 is to plus 28. 0 there, and plus 28. So we've got negative 5y equals, and negative 18, it's a 28, plus 28 is positive 10, and divide by negative 5, I'll just clear the page. So we would have ended up with y equals negative 2. And we have found our y value for our solution. So we haven't found x yet, but we know y is negative 2. So now we're going to find our x value. And to do that, we'll sub in when y is equal to 2 into either equation 1 or equation 2. I might just pick equation 1 because it looks a bit easier to work with. So we'll state what we're doing. So I'm going to sub in y equals negative 2 into equation 1. And equation 1 was this. We had x equals 14 plus 4y. That was equation 1. All right, so now if y is negative 2, let's substitute it into our equation, and there's our y there. And we can see what's going to happen. We're going to have 4 times negative 2. But let's do this. So we have x equals 14 plus 4 times negative 2. So x equals 4 times negative 2 is negative 6. Oh, sorry, negative 8. And 14 minus 8 is 6. And we have it. And your final statement, therefore, the solution is when x is 6 and y is negative 2. And once again, that is the point where these two lines cross over and they share that one point. That is where they are simultaneous. Thank you.